Hey everyone, welcome back to the channel. Alright, let's break down this diagram which illustrates the process of agentic search. We start with a user who enters a query, 1. This is where the magic begins. The initial query goes into what we can call the Agentic Search console, 2. Here, the query is likely processed and refined through query parsing. Importantly, a system prompt is also introduced. Think of the system prompt as the initial instructions or context that guides the entire search process. Next, we move into the agentic reasoning, 3, phase. This is where the agent part really shines. A large language model, LLM, like GPT-4o or Gemini, plays a central role here. It receives the modified input from the console and the system prompt. However, it doesn't just blindly search. It uses a large reasoning model, LRM, like Sonnet, to strategically decide how to find the best information. There might even be a switching mechanism to choose the most appropriate reasoning model for the task. The LRM generates prompts that guide the retrieval agent. This leads us to the retrieval agent, 4. This is the workhorse that goes out and actively seeks information. It doesn't just rely on a pre-built index, it dynamically uses tools, 5. The tools are crucial. These can include knowledge bases, like vector databases and semantic databases, which allow for understanding the meaning and relationships between information. Search engines, familiar ones like Google, Bing, DuckDuckGo, X, formerly Twitter, and LinkedIn, but used in a more intelligent and targeted way. Potentially other specialized APIs or data sources. The retrieval agent uses the prompts generated by the LRM to strategically query these tools. Now, this isn't a one-shot process. The information retrieved by the retrieval agent, 4, is fed back into the agentic reasoning, 6, stage. The LLM and LRM analyze this retrieved information. Based on what's found, the LRM might refine its search strategy and generate new prompts for the retrieval agent to look for more specific or related information. This iterative process continues until the agent has gathered enough relevant data. The result of this reasoning and information gathering is a compiled output, 7. Throughout this entire process, the agent utilizes memory, 8, both short-term and long-term. Short-term memory helps keep track of the current search process and retrieved information, while long-term memory allows the agent to learn from past searches and potentially personalize future results. Finally, after the agent has reasoned, retrieved, and synthesized the information, it generates the output, 9, for the user. This isn't just a list of links, it's a compiled answer, often with citations and the reasoning behind it, aiming to directly address the user's original query. This approach, as seen in engines like Perplexity, has the potential to revolutionize how we find information online, moving from sifting through links to getting direct, insightful answers. Thanks for watching, and I'll catch you in the next one.